Among the longest experiments ever carried out, and one that's still running, is also the most boring because hardly anything ever happens. It started in 1927, when Thomas Parnell, the first professor of physics at the University of Queensland in Brisbane, Australia, heated a sample of pitch, a derivative of tar, and poured it into a glass funnel with a sealed stem. 3 years were allowed for the pitch to settle. Then, in 1930, the sealed stem was cut. From that date on, the pitch has slowly dripped out of the funnel, so slowly that up to the present time, only 9 drops have fallen. The last one fell in April 2014, and for the first time was captured on camera. The experiment stands in a display cabinet in the foyer of the Department of Physics at the University of Queensland, demonstrating for all to see the fact that pitch, though it feels like a solid and is brittle enough to smash with a hammer, is really a fluid of very high viscosity, about 100 billion times that of water. A similar experiment at Aberystwyth University in Wales was recently found to have been running since 1914, predating the Queensland setup by 13 years, but its pitch is stiffer and even after a century has failed to bear fruit. In fact, it's only just entered the stem of its funnel and is unlikely to produce its first drip for at least another 1200 years. If that seems mind-numbingly slow, it's nothing compared to another process that scientists have found. Xenon-124 is a radioactive isotope of the element xenon, a rare and highly unreactive gas. The half-life of Xenon-124, the time taken for half of the atoms in a collection of the isotope to decay, is about 1 trillion times longer than the present age of the universe. It's the slowest process ever witnessed by direct observation. You may be wondering how something that takes on average about 18 sextillion years to happen could ever be detected. It came about as a byproduct of the search for another elusive aspect of nature, dark matter. The Xenon-124 dark matter detector lies beneath 1,400 meters of rock in the largest underground research facility in the world, located in the Gran Sasso and Monte della Laga National Park, about 120 kilometers from Rome. The detector contains 3.2 metric tons of xenon, including a small amount of the Xenon-124 isotope. Although in any sample of a radioactive substance the average time for a decay to happen is given by the half-life, nuclear decay is a random process, and some decays will happen much faster. In fact, over a period of a year, the team at Xenon-124 detected the energy release from the decay of 126 Xenon-124 atoms, a measurement that allowed them to calculate the isotope's incredibly long half-life.